4.2 Translations of the graphs of sine and cosine functions. So now we've gone and we've talked about messing with the period and messing with amplitude. So just as a reminder, when we have our sine and cosine function, I'll use sine as an example. So when we have f of x equals 3 sine times 2x, that's all we've been working with so far. We've only been working with the amplitude and the period. We haven't had anything add or subtract to x yet, just multiplying. Now we're going to do that. That's translations, when we move it left and we move it right. I'm going to show you how to do it by hand, and then I'm going to show you how to use it by doing it by transformations. It's totally up to you and how you want to do it and what best fits you. So horizontal translations, the graph of y equals f of x minus d is translated horizontally compared to the graph y equals f of x. That translation is d units to the right if d is positive, and d units to the left if d is negative. With circular functions, a horizontal shift is called a phase shift. In the function y equals f of x minus d, the expression x minus d is the argument. So a translation, a horizontal translation, is actually called a phase shift. When we move left and right, it's a phase shift. So this is if we did f of x plus 3 and then f of x minus 4. So if it's plus 3, we move left. If it's minus 4, we move right. Just like normal translations and shifts with quadratics and other graphs, if it's negative, you move right. If it's positive, you move left. So let's graph y equals sine x minus pi over 3 over 1 period. Let's do it by hand, and then I'm going to show you doing transformations. So now we have something happening to the x itself. So to the x itself is when we actually have to find what's the transformation, where are we moving towards. But before we do that, let's talk about it just doing it by hand. So method 1. So let's graph this by hand without using transformations or phase shifts. So to do this, we're going to do 0 is less than or equal to x minus d, and that's less than or equal to 2 pi. This is going to find our period. So let's go ahead and make a note right now somewhere where you can, where there's room. I'm going to make it over here. I'm going to do it in bright pink. Okay, so when y equals a sine bx, your period is 2 pi over b. When you have y equals a sine x plus or minus a number, your period is 0 is less than or equal to whatever that argument is, less than or equal to 2 pi. So because we have something minusing or plussing to the x, we have to find our period using this method. Alright, so let's go ahead and plug this in to find our period. So we have 0 is less than or equal to x minus, and that's less than or equal to 2 pi. So the d itself is the number that's being subtracted or added to the value. So it would be pi over 3. So whatever that number is, since it's negative pi over 3, that's why we put negative pi over 3. Remember, the formula is plus or minus. That's why I like to put that. So from here, we just solve for x. So we add pi over 3 to both sides. So then we have pi over 3 is less than or equal to x, and that's less than or equal to 7 pi over 3. So that means our period is pi over 3 to 7 pi over 3. Now, it doesn't start at 0 because we've shifted it. We're either shifting it left or we're shifting it right, so it no longer starts at 0. So, other than that, every other step is exactly the same. We find our intervals and then we go on from there. So let's go ahead and... So other than the first step, everything else is the same. Let's go ahead and find our intervals. So we have pi over 3 and 7 pi over 3. So let's find our first interval, which is halfway. So we have pi over 3 plus 7 pi over 3 divided by 2. So we have 8 pi over 3 divided by 2. That's 8 pi over 6, which reduces to 4 pi over 3. So we have pi over 3, 7 pi over 3, and then right in the middle, we have 4 pi over 3. Now let's find our first quarter point. So our first quarter point is in between pi over 3 and 4 pi over 3. So we have pi over 3 plus 4 pi over 3 divided by 2. So that's 5 pi over 3 divided by 2, which is 5 pi over 6. And then our last quarter point, or our last, yeah, it is a quarter point. We have 4 pi over 3 plus 7 pi over 3 divided by 2. So that's 11 pi over 3 divided by 2, or 11 pi over 6. Alright, so now that we have all of our values, we're going to plug them in, just the first one into our calculator to see where we're starting. And don't forget our amplitude. Our amplitude, we didn't say. Our amplitude for example 1 is just 1. It's just 1 because there's nothing in front of the sine function. So we know we're going to go from -1 to 1. So let's plug the first one into our calculator to see where we actually start. We have sine x, in this case x is pi over 3. And then we're going to subtract that to pi over 3, which we could have just got 0, but still. And we get 0. So since it's positive 1, it's going to go 0, 1, 0, -1. And then back to 0. So on our x-axis, our first point is pi over 3. Then we have 5 pi over 6. Then we have 4 pi over 3. Then we have 11 pi over 6. And then last we have 7 pi over 3. So our first point is at pi over 3, 0. 5 pi over 6, 1. 4 pi over 3, 0. 11 pi over 6, -1. And 7 pi over 3, 0. And we have our chart, or our graph. It doesn't have arrows because it says over 1 period. So we start and stop. So you see how it was just shifted to the right a little bit more? Because originally it looked like this, right? It looks like that when we graph it. But since we have something happening to the x, you see how something is happening to the x? That means we shift it because it's with the x. That's why the x's get shifted. So the first step is to do it just by hand and not care about shifts. That's it. The only thing you have to remember is that when we have x minus or plus something, we have to do this for our period. Method 2 is actually using transformations. Let's go over that. Alright, so to use transformations, we need to start off with y equals sine x. So you need to have in your back pocket what y equals sine x is. So you'd have to have this memorized. Y equals sine x is 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0. So let's go ahead and graph that. So we have our values of 0, pi over 2, pi, 3 pi over 2, 2 pi, and then we have our graph. I'm going to use little dashes to represent this graph so we can just really look at the difference. We put little dashes or change the way the graph looks just so we can figure out what it looks like because we're just comparing it. Now we're going to graph the actual question itself of y equals sine x minus pi over 3. So now we phase shift y equals sine x to the right by pi over 3 units. Remember, it's always the opposite. So if it's negative, it's right. It's positive, we move left. So we need to get the other x values. So the other x values, what we do is just we add pi over 3 to all the x values we already have. So we have the x values of 0, pi over 2 pi, 3 pi over 2, and 2 pi. Those come from y equals 2, or y equals sine x. Now what we do is we add because we're moving to the right. So if we move to the left, we would subtract. Since we're moving to the right, we're going to add pi over 3 to each of them. So 0 plus pi over 3, we get pi over 3. So then our first point would be pi over 3. Then we do pi over 2 plus pi over 3. So pi over 2 plus pi over 3 is 5 pi over 6. So what we do is we add pi over 3 to it. So what we're doing is we're taking these numbers, 0, then we're adding pi over 3. So the next number value we have is pi over 2. So we have pi over 2. Then we're going to add that to pi over 3. And then that's how we get 5 pi over 6. So that's the next x values, 5 pi over 6. And it's always going to fall in between the points we already have. Then our next value, we have pi plus pi over 3. And we get 4 pi over 3. Then our next value we have, we're going to take 3 pi over 2 and add it to pi over 3. And we get 11 pi over 6. Then last one, we're going to take 2 pi and add it to pi over 3. And we get 7 pi over 3. our amplitude didn't change, so our amplitude is going to stay the same and the pattern's going to stay the same. It's just shifting it. So our new points, they're still going to start at 0, so we're just shifting each point pi over 3 units to the right. So we shift this one pi over 3 units to the right. We shift this one pi over 3 units to the right. We shift this one pi over 3 units to the right. We shift this one pi over 3 units to the right, and we shift this one pi over 3 units to the right. And when we connect the dots, you see how the blue to the red, all the blue dots are just shifted to the right pi over 3 units, and that's how we would use transformations. Both very different ways to look at it. Both have their positives and negatives on which method to use. If it were me, I would use method 1. Alright, example 2. We're going to graph y equals 3 cosine x plus pi over 4 over 1 period. So we're going to graph it by hand, and then we're going to graph it using transformations. Transformations is really just showing you and explaining the graph, but graphing it by hand, we're actually going to do all of it by hand. Alright, so amplitude. Let's find our amplitude first. So our amplitude is always the number in front of the function. In this case, it's 3. Now, since it's cosine, we know this first one is going to be 3. That's how we know, because it's cosine. If you don't know that, just plug it into your calculator. You'll still get the same answer. Now we have to find our period. So our period, because we have something with the x plus or minus, we have to do our period using the formula x is less than or equal to x plus or minus, or 0 is less than or equal to x plus or minus d, and that's less than or equal to 2 pi, and d is always that number with x. So we have 0 is less than or equal to x, and the number with x, we have positive x plus 4, or x over 4. We subtract pi over 4 to both sides, so we have negative pi over 4 is less than or equal to x. That's less than or equal to 7 pi over 4. So our period is negative 5 pi, sorry, I keep wanting to say 5 pi for some reason. Negative pi over 4 to 7 pi over 4. Now we're going to break up our period into intervals. So we have negative pi over 4, 7 pi over 4. Let's go ahead and find our first one. So negative pi over 4 plus 7 pi over 4 divided by 2. We get 6 pi over 4 divided by 2. So that's 6 pi divided by 8. And we get 3 pi over 4. Let's find our first quarter point. So our first quarter point is going to be negative pi over 4 plus 3 pi over 4 divided by 2. So we have 2 pi over 4 divided by 2. That's 2 pi over 8, which is pi over 4. Alright, let's keep going. Our last quarter point. We have 3 pi over 4 plus 7 pi over 4 divided by 2. So that's 10 pi over 4 divided by 2. That's 10 pi over 8, which is 5 pi over 4. Alright, if you're unsure about that first y value, go ahead and plug it into your calculator. So it's going to go 3, then 0, then negative 3, then 0, then 3. So we plot it. We have our amplitude of 3, so 3, negative 3. We have our x values of negative pi over 4. Then we have pi over 4. Then we have 3 pi over 4. 5 pi over 4, and then 7 pi over 4. And then we have all of our coordinate points. We have negative pi over 4, positive 3, pi over 4, 0, 3 pi over 4, negative 3, 5 pi over 4, 0, 7 pi over 4, 3. And then it does this little weird curve thing at the ends. And there's our graph. So it's doing it by hand. What if we used transformations? So using transformations, we have to start off with a graph of y equals 3 cosine x. So we start off with the graph y equals 3 cosine x, not y equals cosine x. The reason why we start off with that, because we have that amplitude of 3. So we know our amplitude is still 3. So we would have to know our values of y equals 3 cosine x. So we would know that it's going to be 0, 3, pi over 2, 0, pi negative 3, 3 pi over 2, 0, and 2 pi 3. So the x's for cosine won't change when we're talking about the parent function. It's just the amplitude which is going to change. So that's why we chose 3. So we graph our parent function, which is in red. Right? It's called the parent function because everything spawns from it. So we take all of our x's and we're going to subtract by pi over 4. We subtract because we're talking about plus, so we move to the left. That's why we subtract. So we're going to move everything to the left pi over 4 units. So we do 0 minus pi over 4, pi over 2 minus pi over 4, pi minus pi over 4, 3 pi over 2 minus pi over 4, and then we do 2 pi minus pi over 4, and that's how we get our values. So that's how we get negative pi over 4, pi over 4, 3 pi over 4, 5 pi over 4, and then 7 pi over 4. The amplitude didn't change, so we just shift each of them by negative pi over 4, or to the left, pi over 4. So to the left, pi over 4, 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 and then to the left, pi over 4. Alright, from here on out, I'm not going to be using phase shifts, because it's something that I don't really have to show a lot of examples to understand. You're just going to take your x values and add or subtract to whatever's happening to the x. So from here on out, I'm going to be using method 1 because that's what we need more practice on. Example 3, graphing y equals a cosine b x minus d. So basically putting everything together, let's graph it. So let's graph y equals negative 2 cosine 3x plus pi over 2 periods. So we're going to be graphing this not just in this quadrant this time, we're going to be graphing it over 2 periods, just like we did in example 1 in 4.1. Alright, let's identify our amplitude. So our amplitude is 2. So that means we're going to go from negative 2 to 2. And that means, because it's cosine, the first y is negative 2. Now, we can go ahead and find our period. So we have to identify how should we find our period. Because we have something plus or minus to the x, since we have that right there, we know we're going to be using 0 is less than or equal to x plus or minus d, and that's less than or equal to 2 pi. So just because of that plus to the x, if you have something plus to the x or minus to the x, you're going to use this version to find the period. So we have 0 is less than or equal to 3x plus pi. That's less than or equal to 2 pi. The whole thing inside the parentheses, that's called your argument. Just like remember with logarithms, the thing inside the parentheses is called your argument. So let's go ahead and solve for x. We'll have negative pi is less than or equal to 3x. That's less than or equal to pi. Divide by 3. So we have negative pi over 3 is less than or equal to x. And that's less than or equal to pi over 3. So now we can go ahead and find our intervals. So our intervals, we go from negative pi over 3 to pi over 3. That's our period. So we have negative pi over 3 to pi over 3. Now let's find the rest of our intervals. So smack dab in the middle. So in the middle we have 0. Why? Because those are opposites of each other, but we could also do negative pi over 3 plus pi over 3 divided by 2, which we get 0. Now we find our first quarter point. So our first quarter point is negative pi over 3 plus 0 over 2, which is negative pi over 6. And then our last quarter point, we do 0 plus pi over 3 divided by 2, which is just positive pi over 6. So now we have our values. We have negative pi over 3, negative pi over 6, 0, pi over 6, and then pi over 3. And we know our amplitude is 2. Say this is 2. Alright, we have all of our x values. We don't need to plug them in because we know patterns. Of course, you can always plug them in if you're unsure, but if it starts at negative 2, it's going to go to 0, then to 2, then back down to 0, then to negative 2. So let's go ahead and plot our points. We have negative pi over 3, negative 2. Then we have negative pi over 6, 0. Then we have 0, 2. Then we have pi over 6, 0. And then pi over 3, negative 2. And we connect the dots as best as we can. Remember, it's going to be upside down because it's a negative. So it says to graph over 2 periods. We only graphed it over 1 period. How do I know we only graphed it over 1 period? Because we haven't repeated anything. It goes negative 2, 0, 2, 0, negative 2. You see how we haven't repeated it? So to keep graphing over the other period, all we're going to do is just keep going. And we know it goes back up, right? Yep, that's literally all we do. Is just keep going in the same direction and put your arrows. Vertical translation. The graph of a function of the form y equals c plus f of x is translated vertically compared to the y equals f of x. The translation of c units up if c is positive and c units down if c is negative. So for vertical, it is what it is. If it's positive, you go up. If it's negative, you go down. Just like transformations when you learn them in college algebra, chapter 3.5 and 3.6, or sorry, just 3.5, and just like in intermediate algebra later on in chapters 8. So these translations are not new. None of this is new. What's new is graphing cosine and sine functions and applying what we already know about graphs to them, which I know it sounds much easier than it actually is. So here's what vertical translations look like. If you have 3 plus the function, we go up 3 units. If we have negative 5 minus the function, we go down 5 units. Alright, let's graph y equals c plus a cosine bx. So we're going to graph 3 minus 2 cosine 3x over 2 periods. So you see this number now in front? That's not the number in front of cosine, that's just another number. That tells me we're going to have a vertical shift. That's what that tells me, that we're going to have a vertical shift. So that means we're going to shift up 3 units. Everything's going to go up 3 units. We're not going to start at -2 here. Why? Because we're shifting. When we have a vertical shift, that rule doesn't work. We're shifting. So we'll just plug it in and see what happens. And then I'll tell you from there about the pattern. Don't worry, I got you. Alright, let's go ahead and find our period. So we have to identify what method to find the period. Since there's nothing x plus something or x minus something, we just find the period by doing 2 pi over b. So we have 2 pi over 3, that's our period. So it's 0 to 2 pi over 3. You can find your intervals. We've practiced since 4.1. So our first, it's 0 to 2 pi over 3. Then we have pi over 6, pi over 3, and pi over 2. You can find your intervals. Alright, let's plug in the first one. And then I'll teach you about patterns. So our first one, we have 3 minus 2 cosine 3x. This time it's 0. And we get 1. Alright, let's plug in pi over 6. So instead of 0, it's going to be pi over 6. And we get 3. Let's plug in pi over 3 and see what happens. So instead of pi over 6, it's pi over 3, and we get 5. What do you notice happening with our vertical shift? Alright, let's plug in the next one. When we plug in the next one, instead of pi over 3, it's pi over 2. And we get 3. What do you think it's going to go back down to? Yep, you got it. It's going to go back down to 1. But if you're unsure, plug it in. If you're unsure, ever unsure, just plug it in. So then we have 2 pi divided by 3. And look at that, we get 1. From there, we plot our points. So we have 0, 1, pi over 6, 3, pi over 3, 5, pi over 2, 3, and then we know, 2 pi over 3, 1, and then we know whatever's on the right side, it just keeps going on the left side. So if we had pi over 6, we're going to have negative pi over 6, positive 3. Then we'll have negative pi over 3, positive 5. See, it goes in order. So this is what we have. Using the chart, this is what we have. But we know it's just going to go back up, then back down. So that's how we would finish the rest to get 2 periods. If we wanted to use transformations, we would start off with a graph of y equals -2 cosine 3x. Then we would know the points are 0, -2, pi over 6, 0, pi over 3, 2, pi over 2, 0, and 2 pi over 3, -2. Then from there, we would shift every y value. We would shift every y value by 3 units. So we would take every y value and add 3. So if we added 3, that's how we got the 1. If we add 3, that's how we got the 3. If we add 3, that's how we get the 5. If we add 3, that's how we get 3. If we add 3, that's how we got the 1. And that's how you would use transformations to find your y values. Alright, so regardless of what method you're using, here are some guidelines. Method 1, find the interval whose length is 1 period 2 pi over b by solving the 3-part inequality. 0 is less than or equal to b, x minus d is less than or equal to 2 pi. Divide the interval into 4 equal parts. Evaluate your x values. Plot, draw. pretty much how we've been doing. The only difference is step 1, whether to use this formula or this formula. Everything else is different. Method 2, you want to graph the parent function of sine or cosine with the amplitude it gives you. So if it gave you 3, you would use the 3 sine x. Then you use transformations to graph the desired function. The vertical translation is c units up if c is positive, and c units down if c is negative. The horizontal translation, also known as phase shift, is d units to the right if d is positive, and d units to the left if d is negative. Alright, let's graph y equals c plus a sine b x minus d. So we're going to graph everything we've learned so far with all transformations into 1. So let's graph y equals -1 plus 2 sine 4x plus pi over 2 periods. So when you have a number that's in front of the whole function itself, you can't find your amplitude because it changes your amplitude. So from there, we just move on to finding our period. So our period, because we have something plus or minus to the x, we're going to go ahead and use 0 is less than or equal to x plus or minus d, and that's less than or equal to 2 pi. So we have 0 is less than or equal to 4x plus pi is less than or equal to 2 pi. We subtract pi, so negative pi is less than or equal to 4x, that's less than or equal to pi. Divide by 4, we have negative pi over 4 is less than or equal to x, that's less than or equal to pi over 4. So we have negative pi over 4 to pi over 4. So smack dab in the middle is going to be 0, because they're opposites of each other, that's why. So let's find our first quarter point. So we do negative pi over 4 plus 0 over 2, that's negative pi over 8. And since we have negative and positive versions on opposite sides of each other, we can say this is going to be pi over 8. So now we're going to use our calculator to find the first one, and then from there we can just do it all on our own. Let's find the first one. We have -1. We have -1 plus 2 sine 4x. In this case, x is negative pi over 4. And that's plus pi. And we get -1. Now let's find our second one to figure out what the pattern is. So let's find our second one. Everything is the same except the x. So instead of negative pi over 4, it's negative pi over 8. And we get 1. Now let's go ahead and do 0. So let's go ahead and plug in 0. Instead of negative pi over 8, it's going to be 0. And we get -1. And then let's try pi over 8. So instead of negative pi over 8, it's just normal pi over 8. So let's just get rid of the negative. You could also just type it out all over again. Instead of copying and highlighting and pressing enter, you can just write it all over again. It doesn't matter. So last one, instead of pi over 8, it's pi over 4. We're going to make it pi over 4. And we get -1. Awesome. We have our chart. Now all we do is just graph. So below, that's our graph. So for method 2, we're going to start off with y equals 2 sine x. So basically nothing with it. Just take all the extra fluff out and only use the amplitude. So when we do that, we get points 0, 0, pi over 2, 2, pi 0, 3 pi over 2, -2, and then 2 pi 0. Then for each point, we need to use our transformations. So since we have plus pi, all of our x's we're going to subtract pi by. We subtract because it's plus, it's opposite. So when we do that, we get -pi, -pi over 2, 0, pi over 2, and just pi. So we would subtract pi from each of our x's, and then we subtract 1 for each of our y's, and then we have our new points. From there, you just plot the points, and then you would have your transformed graph.